Have you ever wondered what goes on inside a hemodialysis machine? It looks complex, and it is. This machine is a masterpiece of biomedical engineering, acting as an artificial kidney. Let's break down the incredible engineering that makes it work. At its core, a hemodialysis machine is all about filtration. The magic happens inside a component called the dialyzer, a cartridge packed with about 15,000 tiny hollow fibers. These fibers are made from a special semi-permeable polymer, with walls just 30 to 40 microns thick. Think of them as microscopic straws. Here's how it works. Your blood flows inside these fibers, while a special fluid called dialysate flows on the outside, in the opposite direction. This counterflow design is a classic chemical engineering principle used to maximize efficiency. Waste products in your blood, like urea, naturally move from the high concentration environment of your blood into the clean dialysate. This process is called diffusion. At the same time, a carefully controlled pressure difference across the membrane pushes excess water out of your blood, a process called ultrafiltration. To move the blood, the machine uses a special kind of pump called a peristaltic roller pump. It gently squeezes the tubing to push blood forward at a precise rate, typically between 200 and 500 milliliters per minute. The best part? The pump never actually touches the blood, keeping everything sterile. Meanwhile, the machine is also a mini chemical factory. It mixes purified water with precise amounts of acid and bicarbonate concentrates to create the dialysate. It uses conductivity sensors to check that the mix is perfect, and heaters to warm it to body temperature, exactly 37 degrees Celsius. If anything is off, the machine's fail-safe systems kick in and shut it down. But the most critical part of the engineering is safety. Air bubbles in the bloodstream can be fatal. So, the machine uses an ultrasonic detector that can spot even the tiniest bubbles. If one is found, it instantly clamps the line and stops the pump. It also has an infrared sensor that checks the used dialysate for any signs of blood. It detects even a trace of hemoglobin. It means the dialyzer membrane might be ruptured, and it triggers an alarm. All of this is managed by a sophisticated electronic control system, basically the machine's brain. Microcontrollers and advanced software algorithms constantly monitor pressure, flow rates, temperature, and dozens of other parameters. They use feedback loops to make real-time adjustments, ensuring the treatment is both effective and incredibly safe. From fluid dynamics and membrane science to electronics and materials engineering, a hemodialysis machine is a perfect example of how different engineering fields come together to save lives. Thanks for watching. If you found this interesting, hit that like button and subscribe for more deep dives into amazing technology.